In this lesson, we're going to look at logarithmic functions. And these are functions that can be used to measure the magnitude of an earthquake, the acidity of a solution, the decibel level of sound, and even the percentage of information we remember over time. So, first thing I'd like to look at is the fact that a logarithmic function is simply just the inverse of an exponential function. And we talked about the fact that an exponential function is a one-to-one function, and that since it is one-to-one, it has an inverse. And so we're first going to start off by just writing down the exponential function, right? Y equals b to the x, where b is greater than 0 and b cannot equal 1. And just a reminder of what the domain for the exponential function is. It's all real numbers. The range is from 0 to infinity. And so the inverse of an exponential function is x equals b to the y, right? To generate an inverse, you would just exchange the x's and y's. And so the definition is still the same. B has to be greater than 0, and b cannot equal 1. But now, when you exchange x's and y's, you actually exchange domains and ranges. And so now the domain of an exponential, of a logarithmic function, will be what the range was for the exponential, and the range will be the domain from the exponential. Now, what's different about this expression right here, this equation right here, is that y is not isolated. We don't have y in terms of x. And so when this is the case, we call this an implicit equation, and we'd like to write it explicitly. And so what we're first going to do is just talk about what y actually is. Y is an exponent. And so if we write down verbally what y is, we'll then translate that into a new symbol. So we're going to say y is the exponent on b, resulting in x. Okay. So y is the exponent that we raise b to so that we get x as an answer. This is an awful lot of words, and so in math what we do is we have symbols to replace all those words. And so if I do just a direct translation of this, y would be y, is would be equals, and all of these words, right, a symbol was created to take on all these words, and that symbol is this, the log base b of x. So this expression right here, the log base b of x, means the exponent on b resulting in x. So a logarithm is really just an exponent, right? And it's certainly a confusing topic when you start to think about it, but as you practice, it makes more sense, or it should. So let's look down at the definition of a logarithmic function. Okay. So a definition of a logarithmic function: for x is greater than 0 and b is greater than 0, b cannot equal 1. The logarithmic function to the base b is denoted by y equals the log base b of x. And we see here that the y equals log base b of x is an equivalent equation to x equals b to the y. Now I want to slide back up here for a second and talk about why x has to be greater than 0. Well, since x is equal to b to the y, and if b is always greater than 0, then b to the y also has to be greater than 0. If you take a positive number and raise it to any power, even if it's a fractional exponent or even a negative exponent just takes a reciprocal. It doesn't change the sign. So that's why in this case x is always greater than 0, which makes sense because we just said that the domain of the logarithmic function was the same as the range of the exponential function. And so the range of the exponential function was basically all positive real numbers, and therefore the domain of the logarithmic function would also be all positive real numbers.